Hello. Today I want to inform you about what you can do with a multimeter in the household and workshop. This one I have already some 25 years. I use it in the house. This is the one I use in my workshop, and this is the newest one that I use in my when we are traveling caravan. First, I want to show you how you can earn back the investment in a multimeter like this, and that is by checking the batteries that you may have lying in a drawer. I store them in the fridge. I took the old-fashioned one because it has the largest display. It's now put on voltage direct current DC in the 2 volt position. This one you can put in volt, and it is auto ranging. Okay, let's check. 1.6, 1.62, 1.49, 1.49, 1.61, 1.49, 1.48, 1.62, 1.62. All the 1.6 batteries are brand new. These are used. These also. But they still hold enough capacity to make a lot of equipment work for 1 or 2 years. You can check the voltages. The characteristics can be found on internet. They all have a type number, and you type that in Google and you will find out what tension they should give. If it is lower, then you can throw them away. Okay, that's already more than 2 volts. So I switch to 20 volts range, and then it says 3.28, 3.32. So apparently these are fine. The same you could do with the Vata quality. That's the best quality that you can have. More or less the same count for lithium batteries. These are very powerful lamps, and they work on lithium batteries. They are very, very handy because you can charge them with a USB connection. So that's super handy. This is a lithium battery type 18650. It's by far the most common lithium battery that is on the market. Full, they have a voltage of 4.2. The switch off voltage of a lamp with a lithium battery is about 3.3 volts. So it supplies power between 4.2 volts and 3.3 volts. Well, let's check. The 4.09, 4.14. This is the one I recharged yesterday, and this is the one I didn't recharge, but still full enough to work for hours and hours. Okay, that's about lithium batteries. This is a lead acid battery, gel type, so you can use it in all positions. It's 12 volt, 9 ampere hours, weighs a little bit more than 2 kilos. Lithium batteries, 9 of these cells produce as much energy as this 2 kilo weighing lead acid battery, to have an idea about how much power can be charged, stored in a lithium battery. Okay, in here there are 6 cells of 2 volts, together 12 volts, 1209 to be exact. A battery a lead acid battery in a car or motorbike or scooter that holds less than 9.5 volts should be recharged immediately, and if that happens 4 times, then you can throw it away. Lead acid batteries cannot stand low voltages. Nickel cadmium and nickel manganese hydride batteries like this come from my expensive Canon flash. The flash didn't work correctly last year. They should give a nominal voltage of 2.0 volts, but there was one battery. Then when I took them out and I checked them, there was one battery that didn't work at all. This is 1.3, 1.27, 1.3, 1.3. What I did after discovering that one of these Ansman batteries didn't charge anymore, I replaced it with a somewhat older battery, but with a very high capacity, 2600 milliampere hours. And now everything works correctly. A set like this costs about 15 euros, so saving 15 euros is already almost the price of such a multimeter. We are looking under the hood of my car, 12.49 volts. The funny thing is that I can connect with the minus of the battery, but I can connect also with the car, and then it will show 12.49 also. Why is that? Well, the reason is that the car itself, the chassis, is the minus lead that is used to go to lamps and to the wipers and the radio and all other functions of a car. Normally you would need two wires, but with the car and the bicycle and the motorcycle, one of the wires is the car itself. Because it's iron and that's a good conductor, the car manufacturers simply make a short connection between the minus of the battery and the car itself. Over there, the only thing is that, for instance, the engine itself is mounted on rubber, and the rubber is has a high electrical resistance. So to be able to do the same trick on the engine, for instance for the start motor, which requires a very high current, the engine should have a good contact with the minus of the battery also. And that is done by using the car itself over there with this thick cable running to the engine. You see, with a very heavy, with a very powerful connector, and also of course to the chassis. It's very well connected. This is my 47-year-old renovated mobilette with continuous variable transmission, an automatic clutch, and I have the LED light. I transformed it to a LED light and a horn with a lithium battery, 12-volt lithium battery, and it's full 12.4 volts. And here you can see that there is only a red wire that goes to the rear light and the front light and the horn. The negative wire, so this is the red wire coming from the battery, this is the negative wire coming from the battery, but this wire goes to the chassis, to the frame of the mobilette, and that's one wire. Let's do one more DC direct current measurement on an e-bike battery. It has been charged this night, overnight. To be able to measure it, there are 1, 2, 3, 4, 5 contact points. There is a minus, there is a plus, and I know already that I need to activate the battery in order to do a measurement. It's still on 0, so I activate the battery, and then it shows 41.95, so that's nearly 42 volts. So this battery is still functioning correctly, and the bike is almost 10 years old. A meter like this not only has a position for voltage direct current, but also for voltage alternating currents, AC. And we'll just look how good our power plants in the Netherlands are working correct now. 230 volts. This is earth. There is no tension on that. There is only one wire that pushes alternating current up and down, and when you make a loop by fitting a lamp or another device, then you get a circuit, and there is the other wire that becomes active also, so then you have a circuit. There is another function on a multimeter that is very handy. That's the ohm measuring function, and that is about resistance. Connect one lead over there, one lead over there, and it should come on 0. Okay, let's take the middle one. Near 0. After some thinking, this is also fine. Bulb lamp from a car. Let me check it like this. And there it says there is one contact over there. This is a contact that makes contact with your car, with the steel of your car, the mass we call that. And there is one thick wire over there and one thick wire over there. But there is also a very thin wire in between, and when that wire is broken, the lamp is broken too. And so the current needs to be able to flow through the lamp. These are 5 resistors which I connected with each other, and each resistor has a resistance of 150 ohms. Let me check what the total resistance is of these 5 parallel connected resistors. That's 29 point something, so 30 ohms. Why is that? 150 ohms, 30 ohms over there, because for the current it's 5 times easier to flow through these resistors instead of through one. Apart from the useful voltage measurement, you have the ohm measurement, which is useful to check things on a car. So is a wire not broken somewhere? For instance, if we want to check if this cable here, which connects the minus of the battery with the minus of the car, you could say, you can make a connection over here, and then I'll put that over there, and then take this lead, and you can simply connect it with anything from steel on the car itself. But if so, 0 means that there is no resistance, so that the contact is good. I want to run this 12-volt lamp on this battery, and that works. Well, let me connect it with a 12-volt battery. That's this one. I connect it with this wire, and then it gives bright light because this is 12 volt. But right now I want to check how much current is flowing in this circuit. And that I do by taking a multimeter, putting it in the biggest ampere measurement function, connecting this lead with the 10 amp connection over there, and then make it part of the circuit. So that means that this wire is connected with this, and okay, so now I have created a circuit, so the current goes through the meter, and that is why he can measure 0.66 amps of current. What is happening over here? Well, here I am measuring alternating current with this multimeter, in fact 0.44 amps, and I'm pulling 240 volts from this plug. It's passing through these cables, it goes to this rectifier. This rectifier changes it in direct current, in DC, 13.8 volts, and I can measure the current there also. I remove this, I switch the function to DC, I set to 0, yes, 3.4 amps. Since 13.8 volts is transformed to 21 volts by this thing, the amperage goes down to 2.0, which is actually the amperage that this thing says he is charging the battery with. So there is a little loss in energy over here. The rectifier loses more energy because it's a very old type that I found back, and which serves me now to use in combination with this thing. This meter features also a temperature measurement function, and this one too. I need to put it on temp measurement now, and it's showing 21 degrees. And immediately goes up to 32 on my tongue. It's not very precise, but the measuring range is enormous. Another important advantage of these modern digital meters is that they are auto-ranging. So you simply put it on volt DC or volt AC, the range is determined automatically.